Alrighty. Cool. So, Pata, today's lesson. Oh, before I go, if there is anybody who is going to sit for their exams or anything like that, anybody got any questions or anything before I start up the new grade? Anything like that? Anything you want me to go through again? Yeah, Pata.
Having my exams on. I'm going to have my maths exam tomorrow.
Okay. Is there anything which you want me to go through, or you're already prepared?
Prepared, sir.
Prepared. So if there's anything, Vivian, feel free to during any time of today's class to ask me. Yeah, I'm more than happy. Is it okay if I start up the new lesson today?
Okay, sir.
Yeah. Cool. So let's go to grade 8 then, Buddha. Yeah. So the first lesson for us is number patterns. Grade 8, the first lesson is number patterns. Let's quickly write that down, and I'm going to give you all probably 4 questions to see how well you guys will do those number patterns. I'm pretty sure you all might know about number patterns already. Come on. When we were small, one of the things which we liked most in maths was the number patterns, which was the easiest things. Yeah. So let's see who will manage to find out these patterns properly. Yeah. So the first one is 1, 3, 5, 7, then blank, a blank. Yeah. Then the next one is 11, 14, 17, blank, 23, blank, blank. All right. Then the next one is 3, 6, 12, blank, 48, blank. And the last, but the one which I like most is this. Yeah, not much people manage to find this answer. Yeah, but once they see it, it's very easy. Yeah, 1, 2, 3, 4, blank, 6, blank, 8, 12, blank, 15. Here we go. These are the number patterns today. This is something which I give to every single student when they go to grade 8. So that's why I gave it to you straight away. So every grade 8 first class I'm giving these questions to the students. Yeah. Give your best try. Find out the answers. And if you know it, put it in the chat. So Pute, here we can see that 1 becomes a 3, 3 becomes a 5, 5 becomes a 7. What is happening there, Pute? What is happening here? Who can see? What's the pattern happening here? It keeps on doing what? 2 what, Pute?
2 in the middle.
What do you mean 2 in the middle? What is happening? 1 to become a... adding 2, Pute. Yeah, so it keeps on going up by 2, plus 2, plus 2, plus 2. Yeah, so from here to here, Pute, it's a plus 2, so it's going to be a 9 here. From here to here, Pute, it's a plus 2, so it's 11 here. Pute, if a number pattern, yeah, keeps adding or subtracting by the same number, adding or subtracting by same number, that type of a thing, Pute, we call it, remember this word, it's a arithmetic. Yeah? Arithmetic series. What do we call it, Pute? A arithmetic pattern or arithmetic number sequence. Yeah? And Pute, for this question, we call a common difference. A common difference of a, as you guys said me, the common difference is plusing by 2, add 2. Make sense? Remember these small words, Pute? Very important. Yeah, for your knowledge, common difference is a good word to remember. It's an arithmetic pattern because it's keep on adding by the same number, even subtracting by the same number, we call it an arithmetic pattern. Yeah. Now here, is this an arithmetic pattern, Pute? Is an arithmetic pattern happening here? Is it? Guys, yeah. So what is the common difference?
Adding by 3.
The common difference is a plus 3, isn't it? So this will be a 20. 20 plus 3, 23. 23 plus 3 is a 26. 26 plus 3 is a 29. So here we got a common difference. Common difference of plus 3. Now, this thing which we learned, arithmetic number sequence, I'm going to talk about it extensively today. Yeah, I'm going to talk about it with you all extensively today. Yeah, why? The reason is this thing today is going to come in your O-level paper as well. Yeah, so these type of questions are very popular in O-level papers, and moreover, more than O-level papers. Yeah, moreover than O-level papers today, when you go to until grade, if I'm not wrong, until grade 10, yeah, this arithmetic number pattern is the pattern which is going to come up in your exams. The one after that is called geometric number patterns. Yeah, the one which we are going to learn here. Yeah, geometric patterns. What does it mean by geometric patterns, Pute? Geometric patterns means if a number pattern is keep on multiplying or dividing by the same number. If the number pattern is keep on multiplying or dividing by the same number, that's a geometric number pattern. Now you all can see here, Pute, what is this geometric number pattern? It's multiplying by 2. Can you see? 3 times 2 is a 6. 6 times 2 is a 12. 12 times 2 is a 24. 24 times 2 is a 48. And then 48 times 2 is a 96. That's a geometric number pattern. In geometric number pattern, Pute, this times it by 2, we call it common ratio. What do we call it? We don't call it common difference, we call it common ratio. Common ratio is times by 2. Yeah? Keep that in your mind, but not important. Because geometric number pattern is a grade 11 lesson. We are not going to learn about that. Grade 11. So it's not for you at the moment. But knowing that it is a geometric is not a bad idea. Because it's always nice to know words, nice to analyze things, even though it is not meant for us to learn right now. Yeah. Then the next one. Anybody managed to see the pattern here, Pute? Anybody saw the pattern here? Anybody saw it? Anybody can explain me what's happening here? What is this pattern?
I feel like it's going by 2 and 3.
It's going by 2 and 3. Joshua says it's going by 2 and 3. What do you mean by 2 and 3, Joshua?
Like half of it is like going by
Yep,
1. No,
that is
half
correct.
is also by 1.
Yeah, you're right, Pute. It's actually 2 timetables and 3 timetables, one after the other. Yeah, these are 2 timetables, while these are 3 timetables. We call these things, Pute, yeah, what? Mixed patterns. Mixed patterns are not even taught in O-levels, neither in A-levels. It's pretty much taught in a little bit when I was doing my engineering. I don't know about maths degrees. But engineering, they taught us a little bit to understand how the environmental mixed patterns work. But apart from that, yeah, this is a nice mix. Not these patterns, obviously something more complicated than this. But yeah, this is a good mixed pattern. This is 2 timetables, 2, 4, 6, 8, 10. Then the other one is 3, 6, 9, 12, 15. So it's 2 timetables and 3 timetables jumping up one after the other. Is that clear, Buddha? Everybody? Now, as I said here, under grade 7, grade 8, grade 9, even grade 9, the first lesson is going to be this. Exactly same thing. I gave exactly same questions to grade 9 students as well. About like a couple of days ago. Yeah. So the thing is this. Yeah. In grade 8, they are not expecting you to know everything which I'm going to teach you today. Yeah. But I'm going to teach you all the way up to not everything about grade 9, but more than 75% of grade 9 also I'm going to go through with you today. The reason is, Pute, then it's easy for you to understand the concept. Yeah. Because in here, what's happening in is grade 8 number pattern lesson is made in a way it makes you to think like it is like this, but it's not really like that, if that makes sense. Yeah. So I'm going to teach you all the correct way to think about it. Alright. So let's have a look here. Yeah. Let's say there was a number pattern like this. 5, 9, 13. Yeah. And then blank. Write down with me. Yep. In the above pattern, find the first question. T4 and T5. The next one, the common difference, the general equation, then the term, the value of the 100th term. That means if you go for 100 numbers, what is that number? And the last one is the term which gives you the value of term which gives you the value of 89. Write down the questions there, don't worry. Yeah, I'm going to teach you all how to do it, and after that I will give you all a different question. But this one I will do it with you all. Just write down the question. T4 and T5 Pute, make sure you write the 4 and 5 a little bit smaller than the T4, T5. Write down the question. Once we do this, we have pretty much main parts what we need to know is done. Some people call general term as well for equation. Done with that? Okay. Everybody come here. Now let's have a look. Yeah. Now the first question is asking what is T4, T5? Anybody has any idea what this T means?
Term.
Very good. It is term. Yeah. So Pute, to be honest, mathematicians are very lazy to write words. Yeah. So instead of saying this is term number 1, this is term number 2, this is term number 3, we just said this is T1, this is T2, this is T3. So T4, T5 means they are asking what is the number here, what is the number here. Yeah. So to figure out that number, we need to understand what's happening here or the common difference which is happening. Remember the questions which you are going to get will have common differences. Nothing to worry about geometric or mixed patterns here. Yeah. So what is the common difference happening here, Pute? Can somebody quickly tell me what is the common? Sorry?
Just adding by 4.
Adding by 4. Plus 4, plus 4, plus 4. So 13 plus 4. How much is that, Puta? That's a 17. And then 17 plus 4, that's a 21. So we can write down, Pute, the first answer. P4 is a 17 and T5 is a 21. Is that clear? And then the next answer also we can write it. The common difference is a plus 4. Or you can just write a 4. The general equation. That is the fun part. Yeah. General equation, Pute, what we do is we write down Tn. That means term number equals. Now listen to this properly. If you listen to it properly, it will be very easy for you. Alright. Term number equals Tn equals. Write down what's happening in the pattern. What is the common difference here? It's plusing by 4, right? Plusing by 4 means it's 4 timetables. So we write down 4n. 4 timetables. 4n. Yeah? Is that clear? But is it actually 4 timetables, this one? No. Let's, in those cases, just quickly go up here on top of the number pattern which is given. Write down the 4 timetables here. Here, because it's adding by 4, we will write down 4 timetables up here. 4, 8, 12, 16, 20. Now Pute, take any term you like. Take any term you like. And tell me the timetables to become the number pattern. 4 to become a 5, 8 to become a 9, or 12 to become 13, or 16 to become 17, or 20 to become 21. What should happen? Only using addition or subtraction.
So is it 4n plus 1?
4 timetables, it's a plus 1. 8 plus 1, 12 plus 1. Very good, Dasindu. So 16 plus 1, 20 plus 1. So this is going to be 4n plus 1. The number pattern is 4 timetables with a plus 1 Pute. Is that clear to everybody? Yeah? All good. Now Pute, it's very easy. Now let's say, that we didn't even know the fifth number. The fifth number, we don't know it. All we need to do is 4 times 5 plus 1. 4 times 5 is a 20. 20 plus 1 is a 21. Fifth term is 21. We get the answer. Now they are asking 100th term. That means they are asking term 100. That means Pute, instead of putting an n, put 100. 4 times 100 plus 1. What is 4 times 100? What is 4 times 100? 400. 400 plus 1?
400.
401. There we go. We got our answer for the 100th term. So we didn't even write 100 numbers to find the 100th term. Is that clear? Now the next question is a little different, Pute. Yeah? Next question says, the term which gives you the value of 89. That means if you keep on writing this number pattern, there will be a number 89 coming up. But what term is that number? That means they are asking if the Tn is, what they are saying is, if Tn is 89, what is n equals to? Do you guys get it? They are asking which number it is. So what we do is, we write down the general term first. 4n plus 1, and they say that is equal to 89. Now put there the time to use your grade 7 knowledge about algebra and solve this and tell me what is the value of n. Quickly solve this.
22.
22. Senura says 22. How did you do it, Senura? What is the first step?
Minus 1.
The plus 1 comes to other side as a... So Senura, your answer is wrong, by the way. No, your answer is correct. Yeah. Very good. Sorry, my mistake. Yeah. Minus 1. And that will give you 4n is equal to 88. And then what is the next step, Pute?
4 times n goes 4 divided by 8.
Yeah, the
8
4n means 4 multiplied by n. That multiply by 4 will go to other side as a divide by 4. That will give you n equals 22. So we can write down, therefore 22nd term, yeah, gives you the value of 89. Got it, Puta? Everybody? No problems? Anybody didn't understand any step of this? Is there any step which you didn't understand about what I just did, Puta? Anybody got any questions? Anything which you didn't understand about this or anything like that, Puta? No one? Everything so far so good? Yeah? Wow. And that's good. Because if you know this, Pute, you're almost done with the more than 80% of the lesson is finished. So it's only half an hour since the class started. We are already almost done with the first part of the lesson. Cool. So then, Putha, let's go to let me give you some questions to do by yourself. Yeah, let's see how you guys will do it. Yeah. So write down the number pattern here. For the pattern of 8, 14, 20, blank, blank, blank. Yep. Find the values of 8, 4, 8, and 6 terms. What is the common difference? What is the what will be the value in 56? And then which n value gives you the which gives you the value of 86. And then the last but not the least will be that's it. try to do these questions with them. If anybody needs any help, let me know. What is it? If the pattern is going up by 6, common difference is 6. The term will be 6n pute, 6 timetables. Okay, Amaya? So it's 6 timetables. So if we write down 6 timetables, it will be 6 timetables plus a 2. Yeah? Senura pute, your first answer correct, second answer correct, third answer correct. Senura, third answer. The way you wrote is wrong. It's 6n plus 2, not tn equals tn pute. That's wrong. Tn is equal to 6 and n. N means 6 timetables plus 2. Yeah? And then Senurapute, your fourth answer is wrong. You didn't do the multiplication properly there. Fifth answer is correct. Yeah? So Noshika Pute, I'm waiting for your answer, and Hania Puta, I'm waiting for your answers. Yep. So let's have a look at the answers here, Pute. In case if you didn't understand. Yeah?
So it's the answer for the second plus 6.
Yeah. That's plus 6.
Thanks.
So let's have a look, Pute. 8, 14 and 20, right? We know it's going up by 6, isn't it? Going up by 6. So the next term will be 26. The next term will be 32. And the next term will be 38, Pute. Yeah? So our answers should be 26, 32, 38. Yeah? And the common difference, we know it's going up by 6, so plus 6. Then Pute, yeah, we know the common difference is a 6. So term now, equation is easy to make. Now we know it's 6 timetables, that means. 6 timetables. Let's write down 6 timetables here, Pute. 6, 12, 18, 24, like that we can keep on writing. Now select anything you like here. I will select this guy. Now think about 12 to become 14, what should happen? 12 to become 14, what should happen? Plus a 2, right?
Yes.
Right, plus 2. You write plus 2. Then 56 term. That means term 56 is equal to 6 times by 56 plus 2. 6 times 56. 6 times 6 is a... Now first let's do the multiplication here. 6 times 6, that's a 36. 3 comes to the neighbor. 6 times 5, that's a 30. 30 with a 3, 33 plus 2. 336 plus 2 is 338. Then the next one, they are saying what number gives you Tn value of 86. So let's write down the equation. We know 6n plus 2, they are saying is equal to 86. So this plus 2 will come to other side as a minus 2. And that will give me 6n is equal to 84. Then this multiplied by 6 will come to other side as a divided by 6. And n will be equal to 84 divided by 6, Pute. How many 6 can go into 8? That's a 1, which is a 6. Left over 2, 4 comes down. How many 6 can go into 24? That's a 4, which is 24. Left over 0. So 14th term. Got it, Pute? Everybody? That's how that is done. Then let's go to a small question. Now this is a kind of like a structured type of a question. Write the first 5 odd numbers and find the general term for it. That's the first question. Then using the above general term you got, find Roman number 1 T12, Roman number 2 T15, Roman number 3, n equals how much when Tn equals 89, and then this one you need to use your brains here. Which term is the greatest odd number less than 100? Okay, here we go. This is the question for you. After that, there's only another one more. No, that's it. After that, we will go to special patterns before we have a break. Write the first 5 odd numbers. What are the first 5 odd numbers we have here, Pute? Yeah, we know 1 is the first odd number. Yeah, then 3, then 5, then 7, and then 9. That's it. Got it, everybody? Then find the general equation. Now, odd numbers are going up by what is the common difference of odd numbers? Can somebody quickly tell me what is the common difference of odd numbers, Pute? 2. 2. So it's 2 timetables, right? 2n. 2n. But is it really 2 timetables here? No. Yeah. So in those cases, we just quickly write down 2 timetables on the top, but make sure you rub it out when you are giving the answer sheet. Yeah. And then would they compare one of the set of these numbers? Maybe I will compare about these two. 6 to become a 5. What should happen? You minus a 1. 2 timetables minus 1. Is that correct? 2 minus 1 is a 1. 4 minus 1 is a 3. 8 minus 1 is a 7. Yeah, that works perfectly. So the general equation is 2n minus 1. Would they remember in the exam? Make sure you rub it out afterwards. Don't keep it. Because this is a tactic which I use to get the answer quickly. Alright, next one. Term 12. Term 12 is going to be, instead of n, put a 12. So that will be a 2 times by 12 minus 1. 2 times 12 is a 24. 24 minus 1. That's a 23. Then the fifth, next one. Term 15. Term 15 is going to be 2 times 15 minus 1. 2 times 15 is a 30. 30 minus 1, which is 29. Got it? And then they are saying what number gives the 89. So we will put 89. 89. What is 89? 2n minus 1 equals 89. This minus 1 will go to other side as a plus 1. Yeah. And that will give me, Pute, 2n is equal to 89 plus 1, which is 90. Then this multiply by 2 will come to other side as a divided by 2. 90 divided by 2, 45. So 45th term. 45th term gives you 89. Then Pute, the last question they are asking us is, which term is the greatest odd number less than? Yeah. They are asking, it's a little bit of a, which term value gives you the greatest odd number less than 100. So what is the greatest odd number less than 100? Can somebody quickly tell me? What is the great? 99. So Pute, make 2n minus 1 equals 99 and find out which term it is. Yeah. So bring that minus 1 to other side as a plus 1, and that will give you 2n is equal to, I was wrong, 100. Even you were correct at the very beginning. Sorry about that. Then multiply by 2 comes to other side as a divided by 2. 50th. It's the 50th term. My mistake. Sorry, Vivian.
It's okay, sir.
Yep. 50th term is the 99 number, not the 49th. I was thinking 49, thinking 2n plus 1. Actually, odd number pattern is 2n minus 1. Alright, everybody good, Putha? So far, so good. Apart from this, Puthe, there are a couple of special patterns which we need to remember. But before I go to that, did everybody understand everything until here, Puthe? No doubts, no issues? Okay. Then let's go to the next one, Puthe. Special patterns. Under special patterns, Putha, the first thing we are going to learn is square numbers. Square numbers. So, Puthe, I think you all can remember square numbers, right? How does the square numbers look like? 1 here. Yeah. The next square number is a 2 by 2. The next square number is a 3 by 3. Yeah. And the next square number is a, what Puthe? 4 by 4. Yeah. So if we have a look here, Puthe, term 1 is a 1. Term 2 is a 4. Term 3 is a 9. Term 4 is a 16, like that. Something n by n will be term n equals what? So people were wondering, what is the general term of square numbers? Now, as I said, you can't work it out like the normal method we do use here, because this is a different pattern. This doesn't have a common ratio. Common difference or common ratio either. So people were wondering, is there a way to think about the term number, term n with n? And then they saw this Puthe. How did the 1 made up? Can somebody tell me, how does the square numbers work?
Times 1.
1 times by 1. Yeah, 4 means 2 times by 2. Yeah, this term number 3 made up with 3 times by 3. Term number 4 can be found with 4 times by 4. Or in other words, term number 1 is 1 square. Term number 2 is 2 square. Yeah. Term number 3 is 3 square. Term number 4 is 4 to the power of 2 or 4 square. Then put their term number n will be n times by n, or term n is going to be n squared. There we go. That is the general equation of square numbers. Is that clear, Puthe? Now, will it help us to get... Sorry?
You can write it down.
Yeah. Go for it. So, you can't do much work with it, but you need to remember this equation. That's it. Yeah. So,
Excuse me, sir.
yeah.
Is it Tn equal n square? Is it a general equation?
Yeah, it's the general equation of square numbers. So if somebody asks you, what is the general equation of square numbers? N to the power of 2. Tn equals n to the power of 2. That's all you need to remember. Because you all know, if somebody asks you, what is the sixth square number? It will be 6 times 6, or 6 to the power of 2. 36. Now today, the thing is this, alrighty? By the beginning of end of February, probably end of February or beginning of March, or much before that, who knows? I am going to ask you all, I want everybody to remember the first 20 square numbers. So now I'm going to give you all first 20 square numbers, and I want you all to start to memorize it. Yeah. There's no such a easy way than memorizing. I will teach you all the way I remember. Yeah. But you need to memorize it. Why? For the sake of Puthe getting our questions done faster. So now itself, Puthe, try to write it down in a A4 sheet or something. Keep it near your bed or somewhere, and keep on looking at it and try to memorize them, Puthe. It will be very helpful when we go to the lesson called square roots. Yeah, which is going to be one of the last lessons in term 1, and we will definitely need it a lot. Yeah, until you go to your O levels. Even O levels, there is a square root question always. Yeah, so remembering these 20 will help you loads. Alrighty, are you all done with writing this? Let me give you all the first 20 square numbers. Please ensure that you guys start to memorize them. Then it will be easy for you to understand the lesson when we are doing square root lesson, and it will be easy for me to teach you the square root lesson. Yeah, remember Pute, star point 1, square numbers are always ends with, but there are only some specific numbers Pute. Every number, you will never get a square number which is ending with a 3. No. Always ends with a 0, 1, 4, 9, 6, 5, and 1, 4, 9, 6, 5. Yeah, that's it. How did I write it down? I was just thinking about 1 times 1 is a 1, 2 times 2 is a 4, 3 times 3 is a 9, 4 times 4 is a 16, which is ending with a 6, 5 times 5 is ending with a 25, 6 times 6 Pute, again you can see here, 6 times 6 is 36, ends with a 6, 7 times 7 ends with a 49, 9, 8 times 8 ends with a 64, 9 times 9 ends with a 81, and 10 times 10, 100, ends with a 0. So square numbers are always Pute, no matter what the square number is. It can be a very humongous square number, but it should be one of these numbers ending. If you ever see a number, they are asking you, is 783 or 87 a square number? No, never. Why? Square number should always finish with these numbers. Anyway, 1 square is a 1. We all know that. 2 square is a how much? If anybody knows, quickly tell me. What is 2 square?
4,
4. 3 square?
9,
9. 4 square?
16,
16. 5 square?
25,
25,
5. 6 square?
36,
36. 7 square?
49,
9. 8 square?
56,
No.
64,
64. 64. 9 square?
81,
81. And then 10 square?
100,
Now Pute, 11 square, 12 square, 13 square, 14 square, 15 square, 16 square, 17 square, 18 square, 19 square, 20 square. The fun part is these 11, 12, 13, 14 ends with the same exact number like the before. So 11 square ends with a 1, 12 ends with a 4, 9, 6, 5, 6, 9, 4, 1, 0. It's like a pattern. And how does it end there? Look at the last 2 numbers after this. Yeah. It's a little bit of a pattern is there. It's not an exact pattern, but it's easy to remember. 10 plus 2, 12. 12 plus 2, 14. 14 plus 2, 16. 16 plus 2, 16 plus, after 16 put there, plus 3. 16 plus 3, 19. Yeah, 19 plus 3, 22. 22 plus 3, 25. 25 plus 3, 28. Yeah. Then after that, Pute, you add 4. After 28, so after 6, you add a 3. After 28, you start to add 4s. 28 plus 4, 32. 32 plus 4, 36. 36 plus 4, 40. There we go. So, yeah, that's a little bit of a pattern which you can remember if you want. But end of the day, I want you to remember as 11 square is a 121. Yeah. 12 square is a 144. 13 square is a 169. 14 square is a 196. Yeah. 15 square is a 225. 16 square is a 256. Yeah. 17 is 289. 18 is 324. And then 19 is 361. And then the last one is a 400. All goody? These square numbers we did it in grade 6, right? Can you remember? But we didn't learn it like this. No, Joshua? Can't remember.
I joined in grade 7.
You joined with me in grade 7. Why didn't you pass the grade 6?
I did.
Yeah. How did you pass it? Without knowing it?
No, it's fine.
Did you attach 100 rupees in the paper?
No.
I can still remember there was a guy in my school and he used to attach like 500 rupees, 1000 rupees in the paper in O level, but still he got 9A. No, not 9A, very bad marks. Okay, very bad marks. And I was like, maybe and he didn't get the money back again as a forward. He lost about 9,000 rupees. And still got C's and S's. I don't think he failed. No. He got S's and C's. Very bad marks. Yeah, that's the bad thing, Pute. Yeah. About O levels. Yeah, it's a lifelong result. Whatever the result you get is the result you get for the rest of the life. That's the bad part about this O level thing. Yeah. So you need to take the responsibility and study well. Because end of the day, Pute, even now, yeah, I don't know how many years since I did my O-levels. I did my O-levels back in 2012. I was expecting the world end. Yeah, there was a rumor going on the world will end, but it didn't, unfortunately. Yeah, but yeah, 2012 when I was doing it. I got a 7 A's, 2 B's, and I still regret that 2 B's. I was like thinking, come on, B means what, Pute? B means above 65 but less than 75. That means probably I might have been 70s, Pute. I was looking forward for 90s. Yeah, but still, if I studied a little bit more, I should have gone up here. And since then, now 2012, now this is 2025. It's been how many years, Pute? 13 years past. Yeah, I'm still thinking about that 2 B's. Thinking, if I studied a little bit more, I could have got it. So that feeling will be there. Yeah, unless or otherwise you get the best results. So make sure you give your best. Yeah, now itself, then it's easy. Okay, anyway, triangular numbers. Yeah, Pata?
Can I repeat the 17 square number?
Oh, here we go. 289.
Okay, sir.
Okay, but the next number pattern is triangular numbers. Yeah. Who can remember the triangle numbers? First one is the 1 and then 1, 3. Alrighty, then
6,
yeah, 6. And then
10,
Oh, sorry.
10. 10 to them. Alright, and then
15.
15. Yeah, we keep on adding the numbers, right? But that didn't work much well, Pute, when it came to number patterns, because it's not a pattern, no, it's not an easy way to remember. So term 1 was a 1, term 2 was a 3, term 3 was a 9, sorry 6, okay. Term 4 was a how much, 10, isn't it? And then term 5 was a 15, like that it goes on until the triangle of term n, which we want to find out what is the thing which will help us to get the triangular number pattern. Now let's think about this. Let's think about this term 3 onwards. Using a 3, is there an easy way to make a 6? 3 times what is a 6?
2.
3 times by 2. Okay. 3 times by 2 is a 6. Very good. Yeah. Using a 4, is there a way to make a 10? Or anything, what is the first multiple of 4 which is at least in 10 timetables? 4 times what is in 10 timetables? 4 times?
4.
That's not in 10 timetables, no, that's not even. Anything 4 times 5 is related to 10, right? Yeah. Then let's think about term 5. 5 times what is 15?
5 times 3.
5 times 3. Now Pute, the thing was, this is not that relatable to us. Yeah, because this is times 2, this is times 5, this is times 3. But somebody saw this Pute. Instead of writing 2, what if I write down as 2 as 4 over 2? Yeah. Instead of writing, now we know this is 4 times 5 is a 20. 20 divided by 2 is a 10. Yeah. 5 times 3, rather than writing 5 times 3, what if I write down 5 times 6 divided by 2? Now that makes us a nice pattern here. What is the pattern? The number you want, multiply by the number after that, divide by 2. Yeah, let's check whether term 2 works. Term 2 is going to be number I want is 2 times by number after that is a 3 divided by 2. 2 times 3 is a 6, 6 divided by 2 is a 3. Do you guys get it? Yeah. Number I want, multiply by the number after that, divided by 2. 1 times 2 is a 2, 2 divided by 2 is a 1. Do you guys get it? Yeah. So then we came to the equation Pute. Yeah. What is it? Term 1 is equal to number I want add with 1 plus that number divided by 2. Term 2 is going to be number I want multiply with 1 plus that number divided by 2. Like that it goes on. So I can write down term n is going to be number I want multiplied by the number after that. 1 plus that number divided by 2. The general equation of a triangular number pattern is this. So using this Pute, you can even find the 50th triangle number if you want. What should I do? Triangle number 50 will be number I want multiplied by the number after that divided by 2. 50 times 51 will be 0525 divided by 2, and that's going to be a 1275. 1275. Easy peasy. I didn't even draw any balls to find that. Yeah. So can you guys understand it, Pute? The triangle number pattern is number you want multiply by the number after that divided by 2. The number you want multiply by number after that divided by 2. Yeah. Quickly write down. Yeah.
Is the same that equation triangle number form?
We normally say term number, but yeah, for this is for triangle number equation. Yeah. Alrighty. This triangle number pattern today. Yeah. There is a nice thing, a nice small story about triangle numbers put up. Yeah. There was a German scientist or somebody called Carl Friedrich Gauss. Or Gauss is a very popular name in mathematics today. Gauss have done a lot of things. But one of the main things were infinite series were found by Gauss. And sine and cos and all those stuff. But yeah, there is a funny story about this Gauss. Alright. Gauss was when he found this equation, he was a little boy. Okay. He went to the class. Now that day the class was a little tired. And he was like, oh, maybe not the best day to teach. Yeah. So the sir was like, I don't feel like teaching today. But he can't just wait, no Buddha. So just like a normal teacher, what will he do? Give one of the hardest questions to the students, so then he can have a small nap until the students do the work. Yeah. So what this guy did was, he said, okay, let's say that we added all the numbers 1 plus 2 plus 3 plus 4 plus 5 plus blah 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 until 99. Until 99. What will be the answer? Now, yeah, Gauss heard that and he was like straight away, sir, the answer is this. He was like, it didn't even take Gauss that much of time to say the answer. He straight away said, hey sir, the answer is going to be, what was the answer? 9900 divided by 2, which is a 4, and 1 comes here, and that's a 950, 4950. And then the teacher was like, oh, how did you do it? Yeah. And he was saying, okay sir, if you have a look, yeah, 99, yeah, 98, a little bit of numbers before that, 97. 99 plus 1, how much is that put there? 100. 98 plus 2, 100. 97 plus 3, 100. Yeah. So if you keep on adding like that, it keeps on adding to 100 until 50. Yeah. That means the first 49 numbers adds up to 100 plus a 50. Yeah. So that's a 4,900 plus 50. That is 4,950. That's what he said. Okay. And after that, yeah, he started to think about it in a really different way. He started to think with triangular numbers. Okay, 1 is there, 2 is there, 3 is there, 4 is there, yeah, 5. Now can you see the number pattern of triangle numbers? 1 triangle number, 6, then 1, 3, 6, 10, 15. Like that, Pute, if you go to 99 triangles, what will be that triangular number? That's going to be 99 triangle number I want, times by the number after that, which is 100, divided by 2. Yeah, 99 times 100 is a 9,900 divided by 2. Give me a 1 second, Pute. I'm going to finish the class today. Sorry, I'm taking a little longer. How many 2's can go into 9? That's a 4 left over 1. How many 2's can go into 19? That's a 9 left over 1. How many 2's can go into 10? That's a 5 and a 0. That's how we found it. Does that make sense? So this Gauss, this equation which we have, now we found for this triangle number, actually Gauss is the person who found it. It was not even related to triangle numbers when it was found. Yeah, is still used and still make a big impact, not only in triangular numbers, in many other formats as well when we are using coding and all the stuff. Yeah. So yeah, it is worthy of mentioning his name. Yeah, whenever we go through it, and always remember, if somebody asks you what are the additions of until this number, all numbers, use the triangle number equation, you can get the answer. Got it, Putta? Alrighty, then let's have a break for today. I'll see you guys next time then. And make sure to do the homework which I'm going to send. Yeah, everybody, I want the homework, not like last week, last year. I want everybody's answers. So Kriputa, I'm not going to make the questions hard. I'm going to make the questions easy to do, but make sure that you all get it done now itself. Yeah. I'll see you guys then for that. Have a great week. Bye bye.
Thank you, sir. God bless you, sir. Have a nice day, sir.